Hello, and before we move on, I want to discuss few questions and which will eventually explain some of the concepts which I think will be useful. 1. Probably you know this answer by now, but let me ask again. Chlorine has two isotopes having atomic weights 35 and 37. Now, will it be right to place chlorine with these two isotopes in the same place in the periodic table with halogens? And the answer is definitely yes. Question is why? Because now in the modern periodic table we are not arranging elements based on their atomic masses or atomic weights. Modern periodic table we arrange the elements based on their atomic numbers, which is the number of protons, and we know that proton has positive charge, so number of protons also represent number of electrons. So chlorine having atomic number of 17, that is 17 protons, therefore also having 17 electrons, the electronic configuration is 2, 8 and 7. That means the valence shell, the last shell, is having 7 electrons. So in the periodic table, chlorine or any other element having isotopes will be placed in the same position, whether it is chlorine or it is hydrogen or it is oxygen, doesn't matter. So isotopes have the same position in the periodic table. Okay, so this is based on the modern periodic table, which says that which arranges elements based on their atomic numbers and not on their atomic weights. Now another interesting question which is slightly different from this one. You must have seen while discussing about elements, I showed that there is a nucleus at the center with protons and neutrons, protons having positive charge, and electrons are placed into orbits or shells, and we say that electrons are rotating in these orbits like the planets, like the Earth, like the Mars, like the Jupiter. Now remember, electrons are very small, they are fundamental particles, extremely small, smaller than whatever small you can think, they are so small. Okay, now it is good that if we can think that they are in the orbit, it looks very nice, but do they really exist in this way? We do not know. First of all, it is not possible, because whatever device you discover, whatever device you can think of, it will not be able to take capture the entire image, because they are the fundamental particles, smallest possible particles. So this is a model based on some of the observations, but there is an interesting theory by Werner Heisenberg. I'll write the spelling now. It's called Heisenberg uncertainty principle, which says that it is not possible to predict the exact location or place and its velocity. Okay, this is the theory by Heisenberg, Werner Heisenberg. Okay, it is called Heisenberg uncertainty principle, which says it is not possible to predict the exact location and its mass simultaneously, exactly at the same time, simultaneously. So when I say that particles are rotating around an orbit, that means we can exactly predict where that particle will be at the next moment. So if I have to believe his principle, if according to his principle, and for which there is lot of proof, then this orbit model may not represent exactly how atoms are or how the electrons are in the atom. Okay, So it is not possible to predict the velocity and position of a particle simultaneously or at the same time. This is called Heisenberg uncertainty principle. Then why did I mention it here? So that you do not have a fixation in your mind that okay, there is a nucleus at the center and electrons are in the orbit just the way sun is, sorry, the earth is or moon is or Jupiter is, because based on their fixed position we can always predict the eclipse time and all this time of tide and wave. That is not how fundamental particles like electrons, protons, neutrons, photons, like light particle behave, because fundamental particles behave in a different way than large objects. So this is called Heisenberg uncertainty principle. So I just want to keep it in mind and then move on. Okay, then we will discuss about modern periodic table.